What you should do, though, for the next lab is you should, if you don't remember your linear algebra from first year, very quickly review what you can do with a matrix from linear algebra, and that will help you for tomorrow. Well, for the next lab. All right. So we've talked about what have we talked about? We've talked about how to make a basic class so far. Right? The classes we've implemented so far have been pretty straightforward, I think. Even though it's relatively easy to do, you still have to do it a few times to become comfortable with it. So today we're going to start by talking about one way that you can describe a class without actually writing any software. Without writing any software. Then we're going to talk about how you can test a class or test some methods. And then if there's any time left over, we'll continue with implementing different types of classes. So I want to talk about something called the UML class diagram. We saw this a little bit when I showed you the interfaces. So UML is a visual modeling language. It's used in software engineering to describe or to visualize the design of a software system. Typically, it's used to describe the design of an object-oriented software system. This picture here is a UML picture. So this is the UML language described in UML. What they're trying to show you is the types of, diagrams that you can have in a UML description of a program. Right? So you can see it's actually fairly complicated. There's actually probably more than this diagram is showing. But you can see that everything in a UML diagram is just a diagram. Right? So that thing at the top, that's the most general type of diagram that you can have. Right? And then you can have what are called behavior diagrams. So that's how your program behaves. Right? And then you can have your structure diagram, which is how structure describes the structure of your program. We're really only interested in this thing here, the class diagram. So we're interested in one of the many types of structure diagrams that you can have. So a UML class diagram describes the structure of a class. Right? So it doesn't describe how the methods work. Right? It just says, look, this is what your class is made of. These are the features that your class has. Right. So typically, it includes the name of the class. And surprisingly, if you want, that's all it has. So it just describes it. You've got this class called X, for example. Normally, though, you want to have, not normally. In many circumstances, you want to have more detail of what's in the class. So you can put the fields in your diagram, and you can put the methods in the diagram. UML uses the term attribute for your fields, and it uses the term operations for your methods. Because UML is supposed to be language agnostic, right? So in other words, any object-oriented program should be describable by a UML diagram. So they use these generic terms, attributes and operations, instead of the Java specific terms, fields and methods. All right, so that's your simplest UML class diagram. Right? It's just a box, name of the class. Surprisingly, the type of font is actually important in a UML class diagram. So that font there is supposed to be a regular font. Right? So not italic, not bold, or anything like that. This is the only mandatory information in a class diagram. That's it. OK. But you can obviously, it would be useful in many cases where you would include extra information in your class diagram. So if you want to, you can add a second box under the first box. And in that second box, you can list one or more, so I guess 0 or more of the fields belonging to your class. Right. So the first symbol here is typically the access modifier. The second thing is typically the name of your attribute or field. Then there's a colon, and then there's the type. Right. So again, it doesn't match what you do in Java. But that's because UML is not supposed to be specific to any type of object-oriented programming language. When you list the fields, the text is supposed to be left justified. Question, yes?
So does the minus sign mean private?
Yeah, I'm going to show you that in a second, right there. There you go. Right, so your access modifiers, there's 4 in, I guess there's 4 in many object-oriented programming languages. Or I guess the better way to put it is that these 4 will cover the access modifiers that you have in most object-oriented programming languages. Right, so you have public, which is just a plus, minus is private. The tilde is package private, and the hashtag is protected. So obviously for now, most of ours are going to be either public or private. Oh, sorry, I forgot to mention, if you're following in the slides, I updated this set of slides today. So this is slide set number 14. If you want to, you can then you can then list the methods in the next part of the diagram. So you just add another box underneath the second box, and you list your methods. So your methods, they can have an access modifier. Then you follow it with the method name. Then you follow it with the parameter list, and then you follow it by the return type. So again, different than the way you do it in Java. You can put your constructors in here as well. So for our point2 class that we have so far, that's what we have so far in our class. Right? Our class is point2. We've got two private fields. Oh, wait, sorry. I just realized there's a mistake. Those are double. This is a copy and paste error from a previous, from a lecture long ago. Okay, so we've got our two fields, x and y. Right? They're both private. Their types are both double. We've got a bunch of public features here. There's our no argument constructor. Now here's our constructor that takes in an x and a y coordinate. So the way you write this in UML is it's the name of the parameter, then the colon, then the type of the parameter. Right? Comma, y, colon, double. Right? So that constructor there takes in an two double values, x and y. Here's our accessor method called x, and it returns a double. Right? So that returns the x coordinate of the point. Right? There's our accessor method y. Here's our mutator methods x and y. I think these are a new x and new y in our slides. So this is the method that changes the x coordinate and returns a reference to the point. Right? There's our method that changes the y coordinate and returns a reference to the point. And here's our method that changes both the x and the y coordinate and returns a reference to the point. And finally, there's our toString method. Right? So toString, no arguments, no parameters, and returns a string. Right? If you actually look at the point2 class implementation in the notes or in the source code for the class, you'll see there's probably another, how many? Dozen? Maybe more. There's quite a few other methods in the point2 class. Right? We just haven't talked about them yet. If your class implements an interface, you can indicate that as well. So classes that implement an interface or interfaces can be shown using what's called the lollipop notation. Right? So ArrayList implements the list interface. So the way you indicate that is you draw the box for ArrayList. Right? If you want to, right, you can put in the fields and the methods belonging to ArrayList. It depends on what you're using the diagram for. Right? You draw a line and then a round empty circle and then the name of the interface beside it. Right? So treeset implements the sorted set interface. Now these classes actually implement multiple interfaces, so you can show the extra interfaces. So you can draw a little, it doesn't matter where you draw these things. So you can draw a little line going up, and then a circle, and then you can put the collections interface, because it also implements the collections interface. Right? Same with the tree set. Although you'd probably show that in a different way, but anyway, it's fine. Right? You can, if a class implements multiple interfaces, you can attach all of the interfaces to the class. And so that is the basic introduction to how to draw a UML class diagram. So in the lab, I'm actually going to ask you for one of these. This week's exercise is a design exercise. It's not a coding exercise. So you're going to have to design a class or classes, and you're going to have to somehow describe that design to your TAs. Right? So this is one useful way to do that. Okay. Now I'm going to talk about introduction to testing. So you've done some testing already in this course, but the testing you did was kind of ad hoc. Right? Basically, either you wrote a main method or I wrote a main method, and you ran the main method where the main method called some method, and you looked at the output and said, yes, that's right, or you said yes, or no, that's incorrect. Right? So testing is a vital part of the development process. So in every modern, well not every, in most modern programming jobs, a big part of the job is testing. it's such a big part of the job that there might actually be one or more programmers whose only job is to test. Right? If you're into video games, then a job that you can get, a bad job that you can get, is to become a tester for a video game. And what that involves is you basically play the video game for like 8 or 12 hours a day, and you try to do all the stupid things that you can. Right? So you try to run into all the walls, you try to mash the menu as fast as you can, and all sorts of other crazy things like this until you find a bug. And then you report the bug to the developers, and then the developers go and fix that. Apparently, it's an awful job to have. Doesn't pay very well, and it's not that fun either after the first few days. Right? So testing code is important. The goal of testing is to find mistakes in your code. So the interesting thing about testing is that it can't actually show that there are no errors in your code. Right? All it shows is that everything that you've tested either works or it doesn't. Right? It doesn't prove that your code is correct. Right? It simply indicates that, you either have found some bugs or you haven't found any bugs. Edgar Dijkstra is a famous, I guess he's many things. One of the things he's known for, though, is his contributions to computing science. All right, so in the previous labs, what did we do to test our code? Right? Either you didn't test your code, you just implemented it and assumed it was correct, right? Or you wrote a main method, or several different main methods, right? Ran the main method and looked at the output. Right? So testing with a main method or multiple main methods has some very serious disadvantages. Right? Probably the biggest one is that someone has to look at the output of the main method. Right? So you have to run, someone's got to run your code, someone has to run the main method, look at the output, and determine, is that output what we expected to see or not? Right? If you write just one main method, then all of your tests live in that one main method. Right? And so what's the problem with that? It means you have to run all of your tests every time. Right? So there's no way to pick just one test and run that one test, or to pick a few tests and just run those few tests. Right? And so there's no easy way to choose which tests actually run. Right? There's no way to automate. There's no good way to automate this either. Right? So a big part of modern software development is what's called automated testing. Right? So the way this works is you create some repository somewhere using some sort of revision control system. So like GitHub, if you know what GitHub is. Right? Every time someone commits code to the repository, the tests automatically run. Right? So as soon as someone uploads a piece of code to the repository, automatically all the unit tests or other tests for that code run. A lot of repositories are set up so that the commit doesn't work if the tests don't pass. Right? And so testing is basically, so it's an important and normally automated part of modern software development. So how do you do this? How do you actually test in a principled way? You use what's called a test framework. Right? And there's many of these. So the one we're going to use in this course is called JUnit. There are lots and lots of other alternatives. JUnit's probably one of the most well-known. There is actually a JUnit 5, but it's hard to use JUnit 5 in this type of course because JUnit 5 uses features of the Java language that we never get to in this course. Yes? Sorry, go ahead.
From a few slides back.
Yep.
When you were talking about the video game thing.
Oh, yeah, okay, sure.
What, like, if someone tests your program for like whatever 12 hours,
Yeah.
and they don't find any bugs,
Yeah.
like, how could it still be wrong?
Because they didn't run into the case where the bug appears.
Oh, so,
Right.
okay. So
Yeah.
you're saying like these tests aren't like thorough enough, basically.
Yes, but you'll see shortly that it's impossible. It's going to be either impractical or impossible to test every possible case. That's going to be the problem. That's a good question, though. Video games are famous for finding for bugs. There are games that have been played for many, many, many years, and then only after many, many, many years have people discovered things about the game. So people who speedrun, if anybody watches speedrunning videos, they try to exploit these bugs in order to finish the game as fast as possible. Question?
That was my question.
Yes.
No,
Sorry.
you answered it.
Oh, okay, good. All right. Video games are very complicated as far as software goes. They're very hard to test. It's also not surprising that most video games release with lots and lots of bugs. Yes. Do you have a question?
What kind of testing runs when you upload it to GitHub, for example? Is it just like the standard throws, or?
I'm going to show you one of the typical tests that will run, or one way that you can automate your testing using GitHub. I'm not actually going to show you the automated testing part. I'm going to show you how you can, one of the ways that you can test, and the way that I'm going to show you can be automated. Yeah. All right, so JUnit 4 is what's called a testing framework. Right? Now, a framework is just a partially completed application, right? So it's partially completed software. So what a framework lets you do is it provides you with a reusable common structure that you can use to implement something, right? So a test framework is a semi-completed application that lets you test your software, right? So in other words, it provides you with a bunch of ways in which you can write test cases in order to test your software, right? It doesn't by itself form a complete program, right? It's up to somebody else to write the tests, thus completing the test program. Okay, so what's a unit test? All right, so a unit test examines the behavior of what's called a distinct unit of work. Now, within a Java program, the distinct unit of work is normally a single method, right? So that's what we mean by the word unit, right? Unit, quantum, whatever you want to call it, right? The smallest possible piece of code that you can independently test. Typically in Java, it's a method. But you can also unit test a class or other things as well. So a unit of work is a task that isn't directly dependent on the completion of another task. So what they're trying to say there is that if you write a unit test for something, then you ought to be able to run that unit test independently of anything else. Okay, so remember this max2 method that we talked about like 3 weeks ago? So we had this funny implementation of max2, where max2 computes the max of A and B in a very weird way. Right? At this point in the course, if you just look at that method, you should be able to tell when this thing works and when it doesn't. Right? But let's go ahead and actually try to test this thing using JUnit. Right? So if I wanted to test this thing in JUnit, what you would do is you would have a class that has max2 in it. So I have that. Right? So there's my class testing. Right? All it has in it right now is my method max2. Right? And I now would like to write a JUnit test for this method. So the way you can do that in in Eclipse is down here in your project, just right-click, right? Go to New, and then find JUnit test right there. Right. Click on that, and then you'll get this little window here. Right. For our purposes, you want to use JUnit 4, not JUnit Jupyter. And that's all you have to do at this point. Right? So just click that, and then click Finish, and then we'll do the rest of it ourselves. Right? So that's going to ask you, do you want to add JUnit to the build path? You say yes. Right? And if you're in Eclipse, JUnit comes as part of Eclipse. If you're in Visual Studio Code, which at least one of you is, I don't know what you do. I haven't tried to do it in VS Code. So the JUnit creates a class for you. So this is called testing test. You can change that if you want to, right? It creates a class. It imports some stuff for you up here, right? And then it gives you one empty test method. So this method here has this annotation, right? It says @test. Any method that has that annotation on it inside of a JUnit test case, JUnit will consider that as a test case. So what that means is when you run your test class, it will run this method as though it were a test. Right? So we can actually run this test class right now. Right? So with the test selected, you can right-click, do run as, and then you can choose, run as, JUnit test. Or if this is open in your editor already, you just click the run button. Right? And when you run it, you're going to see something over here. So this thing pops up over here. And if you can, the tab up here says JUnit. So these are the results, or this is the summary of your JUnit tests. Right? So it tells you that there was 1 out of 1 tests run, none of the tests resulted in an error, but one test failed. Right? And if you look very closely, you can see there's a little blue X here. Right? So a blue X indicates that the test ran, but it did not produce the expected result. If you get a red thing beside it, that means that the test ran or didn't run because there was either a compilation error or there was an exception that was thrown that was unexpected. Right? If you look down here, it actually tells you, it might tell you some extra information. So this says that the test was not yet implemented, therefore it failed. Right? And if you look at the code inside the test method, the reason it failed is because there's this method called fail that causes the test to automatically fail. Right? So the fail method from JUnit automatically fails the test. Right? So we can get rid of that now. OK, so I actually want to test the method called max2. So I'm going to rename our test. Right? And I'm actually going to break the rule where you don't use the underscore in a method name. I'm going to insert an underscore here because I think it's easier to read. So I'm going to write test max2. Right? If you don't insert the underscore there, you have to do it in camel case, and then it becomes test big M max2, which doesn't look like the method you're actually testing. Right? I'm actually testing the method little m max2. So I like to insert the underscore here. All right, and now you write your test case. So when you write a test case, right, you need to determine, right, how am I going to call the method? Right? So in other words, you need to pick what arguments are you going to pass to the method. Right? When you decide what arguments you're going to pass to the method, you have to determine, OK, so what is the expected result of running the method with those inputs? Right? If the method returns a value, then typically you're going to test, does the method return the right value? Right? If it doesn't return the value, or if it does return a value and also does something else, right, then you also need to determine what are the other expected results that your method is supposed to perform. Right? So we'll look at examples of those. Will we? I don't know if we'll look at examples of those in this lecture. But let's go back to max2. OK, so I need to pick some values to run max2 with. Right? So I need to pick 2 int values. Right? So where's max2? To get back to your package explorer, just click that tab up there. Right? And that will take you back to your package explorer. If you want to look at the results of the test again, just click the JUnit tab. OK, so max2 has an A and a B. So I'm just going to make variables A and B. 0 and B equals 5. Right? So if I run max2 with those 2 values, what's the largest of those 2 values? Well, it's the B. Right? So my expected result is B. Right? So I use exp for the expected answer. Right? OK, and now it's pretty simple. You just call the method and remember what value you got. Right? So I'm going to call the method. Got equals what's it? Sorry, it's in testing max2 AB like that. Right? So in this case, max2 returns the value, and it's the returned value that I want to test if it has the correct result. Right? So call the method with your values that you've chosen. Right? Remember the answer. I would normally call it got, but you can call it whatever you like. Right? And now you want to ask JUnit to compare the expected answer and the answer that you actually got from the method. Right? So the way you ask JUnit to compare that result is as follows. Assert equals expected and got. So JUnit has a bunch of methods called assert something. Right? Sorry, I'm missing a there. Called assert something. Assert equals is the one that's most commonly used. So assert equals tests whether or not that value is equal to that value. Right? If they are, then nothing happens. The test succeeds. Right? Well, the test succeeds here because the method ends. Right? If the expected value is not equal to, if those 2 values are not equal, then the test fails. Right? So if you save that and now run our class again, right, you now get the green bar. Right? It tells you 1 out of 1 test ran, there were no failures, there were no errors. Right? If you expand the result, if you click on that stupid little arrow, which I don't know why it's so small, right, you can look and see that test max2 ran. There's a green check mark beside it. Right? So our test, for our one test that we wrote for max2 succeeded. Right? And now to answer your question, I guess, is now that our test has succeeded, do we think that our method is correct? Right? Or have we proven the method is correct? The answer is no. Right? And the reason you haven't proven the method is correct is because I only tested one pair of values, A and B. Right? To prove that max2 is in fact correct by using testing, you have to use every possible pair of values, A and B. Right? So how many pairs of values are there? So an int has 2 to the 32 values, right? And A and B can have any one of those values. So there's 2 to the 64 possible inputs to this method. And you're not going to test all 2 to the 64. Yes?
Is it possible to do like a loop in the test?
Sure, you can. Yeah. Let's write a separate test, and let's do that right now. So it depends on who you talk to about that. Okay, so I have to give this a different name now. So I like to number the tests. So typically I'll number that as 0, 1, and this will be 0, 2. This is not the only way to do it. There's lots of different ways you can name your tests. Sorry, so there's that question. And your question?
So I remember you mentioning last class that assert is like ignored unless you turn it on in Eclipse. Is that true also for
No.
assert?
So this is actually a method that JUnit defines. So this method comes from this class called org JUnit assert. So the full name of this method is actually org JUnit. Like, whoops. Assert equals. So that's the full name of the method. That's the fully qualified name, right? So it's actually a method. It's not the keyword assert. That's part of the Java language. Okay, so can you write a loop? And the answer is yes. So should you do it? The answer is it depends on who you talk to. Many people who do professional testing will say no, you shouldn't write the loop to do it because you end up with many test cases inside of a single method, and then it becomes a little bit harder to figure out exactly which test case failed. So if you just write a plain old loop, it'll tell you that somewhere, so one of the test cases in this method failed. Depending on the message that you output, you may not be able to tell which one failed. Right? So that's the annoying part. Now, that actually leads to how you actually do this. So there's something called a parameterized test, which takes in many possible inputs and also has also knows the expected outputs, and that can run. That basically uses a loop, but when that type of test runs, it actually tells you which one of the test cases failed. Yeah.
So instead of doing the loop, do you have to like manually test each case?
Yeah. So that would be one way to do it. You'd write a separate test case for each method. You'd write a separate method for each test case. Then your classes get really big.
Okay.
Yeah.
Okay.
So that's why there's a parameterized test, but there's no way I can tell you how to write a parameterized test in this lecture. In like week 12, I can tell you how to write a parameterized test, but I can't tell you how to do it now. It won't make any sense to you. Yeah.
I just don't get, like, let's say I'm looping over 500 values
Yeah.
and it says fail.
Yeah.
Why can't I just loop over the first, like, 250 and then see if that works, and the second it's just, like, making my loop interval smaller? I feel like that might be more.
That would work, but that would suck to test your code, right? You actually want to see which test case failed when you run your tests, right? You don't want to have to go in and adjust your methods and say, oh, it's this one that actually ended up failing.
So writing out, like, 500 individual ones is better than that?
No. So that's why there's this ability to write what's called the parameterized test.
Oh.
Yeah. Unfortunately, there's no way to describe how to write a parameterized test to this class because of where we are, of what we know of the Java language right now. All right. So can you write a loop, though? The answer is yes, you can write a loop. So to write a loop, right, in this case, you would probably write a loop over a bunch of A values and over a bunch of B values, right? So you'd write your loop like this, for int A equals. So now something like -5, A is less than 5, A plus plus. I don't know, -10. And now just do this. right? And now you can run that test as well. So now 2 tests will run, right? That test will run, the second test will run. These are both going to pass. Right. Oh, hey, 1 failed. Nice. Actually, it shouldn't have failed. That's bizarre. What happened here? Oh, yeah, yeah. So here's the problem. Here's one of your. OK, so we have to make sure that when I run this test. Oh, that's actually a good. Oh, wait, this is never going to work. So I have to make this bigger than 5. 6. That's actually good that that happened. All right. Come on. Sorry. I'm trying to hit. There you go. OK, so now you can see that both tests ran, and now they both passed. Right? And that was good that I just did that because that shows you one of the problems with writing tests. Right? So the problem with writing tests is you have to write code in order to run a test. Right? And now you have the problem of how do you test the test. Right? So in this case here, it was relatively easy to fix the test. But in some cases, it's, you can write a test case. It looks right. But it turns out there's an error or errors in your test case. And now you have to debug the test cases. OK, so you can, in fact, write a loop. And you can, in fact, call assert equals inside the loop. So that will work. What else is there? Oh, so let's write a test case where it actually fails. There you go. So at test. OK, so I'm just going to copy the code from up here. Paste it in here. OK, so if I want to write a test where this fails, right, if we go back and look at this method here, right, so and you ask yourself, so when does this method fail? Right, it's probably going to fail when that overflows, or when all of that overflows. Right, and so it's easy to make that. It's easy to write that test case. Right, so I can make a plus b overflow just by making b integer max value. Right, and make a 1. Right, so now the sum a plus b overflows, and we're probably going to get the wrong. We're probably going to have a failed test, and you do. Right, so if you look at the error message here, right, it says the expected answer was that's integer max value, right, but we ended up getting -1 instead. Right, and so there is a test case that shows that max2 method is in fact incorrect. Right, and you can write multiple test cases where this will fail. Right, if that overflows, you can get the method to fail. Right, if the first sum doesn't overflow, but then the total sum overflows, that will also cause the method to fail. Right, so that's not a good implementation of max2, but I think you all knew that already. And so there's a, so that's a quick way, that's a quick introduction of how to test the max2 method. Right. So some problems with testing, right? Obviously that you don't want to, so when you write, when you're testing a method, you have to, there has to be some intelligence behind the testing because you can't afford to test all of the possible inputs. At least, well, not even in this case, right? So you have to decide, you have to look at your implementation. So go back to your method, right? Examine how it's implemented, and then now you have to pick your test cases that might reveal errors in the implementation. Okay, so we've done all of this already. We've talked about assert equals. Oh, when you use assert equals, it's always the expected value first, and then the value that you got second. If you flip the order, then the error message that you get back when you're reading the result of the test, it has the results in the wrong order, and it becomes very confusing. Yeah?
What's the point of using like this special test case? Could you just output the values that you get?
You don't want to. So you don't want to output values. You don't want anybody to have to read the output of something to indicate that there was an error, right? All of this stuff up here, this is all generated automatically by JUnit. So you could have like literally thousands of test cases, right? You don't want to look at the output of 1,000 test cases inside of a main method, right? But just looking here, you can determine which one failed automatically. You can even write code to process the results of the tests. So you can write code that actually tells you which test failed, and so on and so forth. Yes?
When you're writing tests,
No, you would write tests for, like, even if you were just a sole developer,
Yeah.
you would write your own tests.
Okay.
Yeah.
To test your own.
Oh yeah, for sure.
Okay.
Yeah. I guess short story time. So when I first started teaching, I was teaching at York University, and I showed up, and they said, "Hey, we got this course we need you to teach," and it turned out to be introductory Java course. And so I said, "Sure. You'll be teaching with so and so." I said, "Great. They've been teaching this course for a long time." So we'd go to set the first assignment. You'd set the assignment, and then I'd ask, "So how do we mark these things?" And they'd say, "Oh, we just print these out and we look at them, or the TAs look at them." I was like, "Okay, if that's the way you want to do it." So went through a whole term of this. So the TAs would get these big stacks of paper, and they'd have to go through on pen and paper and mark your code, right? And so you'd give the TAs the answers, or the quote unquote what you thought were the answers, right? And so they just compare the two. The next year, I said, "Well, this is stupid, right? Now that I've been teaching for a term, there's got to be a better way to do this." And so I said, "Well, look, I'm just going to write my own unit test for this, and I'll give the TAs the unit tests." So I wrote unit tests for the previous term's assignment, and all of the assignment solutions had mistakes in them. So it's because no one ever tested them. No one ever unit tested them properly, right? They would just run them like most of you would run your program, right? Write a little main method, try it out, see if the output matches what you'd expect, but no one would ever rigorously test the code. So it turns out all the answers that we gave the students the previous term, they were all wrong. Testing is very useful. It's like documenting your code. It's very tedious to do. If I'm making an assignment for SISC 124, it takes me about twice as long to write the tests as it does to actually write the code for the assignment itself. And then I have to write the documentation for it as well, so that takes a lot of time too. Okay, so there's something called test-driven development. In test-driven development, you rely on tests or automated testing in order to help you develop your code, right? So in a nutshell, the way this works is you want to write, suppose you want to write a class that does something, right? Before you write the class, you write your tests, right? So in other words, you design your class, decide all the methods that have to be in your class, and now you start to write tests for all of your methods before you even write the methods, right? Now you start to implement your class. Class is empty. You run all your tests fail. So now you start to write your code, right? So now you start to implement method number 1, right? Run the tests again. If the tests pass, you proceed to the next step, right? Write method number 2, right? And then so on and so on and so on. As soon as the test fails, you go back and fix your code, right? And this repeats all over and over and over again, right? If you're doing this all through a repository, you can actually automate the running of your test code every time you make an update. What time is it? Okay. Thank you. Lab 1. So when the TAs get from me the following. Right, so remember lab 1 where you had to write some simple methods that do the forward difference or the central difference or something like that, and then there were a pair of methods inside your array utils class, right? So when the TAs get the marking from me, the code for marking, they get a bunch of unit tests, right? And your code gets run against the unit tests, right? So there's an example of a test that tests whether or not a method throws an exception. Right? So you had this method called cdiff, right? Cdiff throws an exception if the spacing, I guess I should have called that h, right? If the spacing is 0 or negative, right? So all I have here is a little loop that tests a bunch of different spacing sizes that are all negative or 0. Right? Now this is inside of a try and catch construct, right, which you also saw in the previous lab. Right? So I'm going to try to call cdiff, right, with some inputs. One of them is bad, right? So the spacing here is negative or 0. right? If your code is written correctly, right, that thing will throw an exception, right? So what I do is I try to catch the exception that's expected, right? So I'm going to try to catch an illegal argument exception, which is the exception you were supposed to throw if the spacing was negative, right? When I catch the exception, if it's an illegal argument exception, that's fine, right? That's what we expected your code to do, right? So that's why there's a little OK here, and we do nothing, right? This second catch block catches all other exceptions, right? And so if you threw the wrong type of exception, we'd end up here, in which case the test fails, right? If you don't throw an exception at all, right, then that thing there, sorry, if you don't throw an exception at all, oh, that's supposed to fail up here. That's also supposed to fail, right? So if you don't throw an exception at all, right, then you get to the next line, which also fails. Sorry, Control S. So if we just pop open diff for a second. So that's what your method should have looked like, right? If I comment out the exception and run this thing here. Oh. Come on. Where did it run? cdiff throws. OK, try cdiff. That should have had. Oh. Why did that not? Oh, sorry. That should have thrown an exception. Throw if h is less than or equal to 0. Do not throw an exception. So that should have. Why did that not fail? That should have failed.
If you changed it in half diff, not cdiff.
Oh yeah, thank you. cdiff. Here we go. Comment that one out. OK, now you can go back and run this. So you can also run it from here. Just run all the tests again, and now it fails. Right. Down here, yeah. Right, and down here you can see, you can actually click on the test that failed. So if you double click on that, it takes you to the line where the test failed. OK, so there's a bunch of other test cases in here for the methods in the lab. But this is showing you an example of how we actually mark your work, or how I mark your work anyway from the labs. OK, so I guess we'll stop there, since it is quarter after, and we'll talk about static features in a class in the next lecture.